Welcome. In the previous video, we added string tokenization to our tokenizer, and in this one, we're going to start building a dynamic array library. We can begin by creating a da.h file, add all of the boilerplate code, then we can include stdlib and assert, and for now, we can have a single macro, da_append. We are going to use the do while trick to wrap our macro, and since we want to append an element to our dynamic array, we must first check if the dynamic array count is greater or equal to the dynamic array capacity, because if that's the case, we need to increase our dynamic array capacity. Then we need to increase our data size using realloc. And finally, we can assert that the reallocated data is not equal to null. Then we can copy our elements, and lastly, we can increment our count. As you can see, this is completely generic and will work with any structure as long as it has a count, capacity, and data fields. Now, inside our tokenizer.h file, we can create a token structure that contains a count, capacity, and data fields as mentioned. And finally, we can create a tokenize function that is going to accept the tokenizer and return all of the tokens from that string view. Inside the body of our tokenize function, we can begin by defining a zero initialized result. Then we can loop while the tokenizer sv.count is greater than 0 and shop each token one by one. We can also check if the last token we shopped is equal to token end of file, and if that's the case, we can return the result. Otherwise, we can just append it to our result. And finally, we can just return result. Now in our main.c file, we can delete all of this code and replace it by a call of tokenizer_tokenize. To print all of the tokens, we can loop from 0 to tokens.count and then make a printf call. Do not forget that in our tokenizer.h file, you'll need to include da.h. Then if we run our script, you'll be able to see that the string is being properly tokenized. And this is how you work with generic dynamic arrays in C. In the next video, we are going to implement a parser with a minimal abstract syntax tree.